Okay, on to the 2023 Calculus BC AP exam. This is FRQ number 4. We had an average on this one of 4.5, still above the global average, which was only slightly above the Texas average. You go Texas, yeah? Anyway, okay. This is a low-scoring problem for a problem like this, for a graphical analysis problem. A low-scoring problem. So let's see what made this one hard. Usually these have much higher scores. Okay, very low for this type. Okay, graph of f. They give us the graph of f prime. Function f is defined from -2 to 8 and satisfies f of 2 is 1. Okay, we will very likely need that. F of 2 is 1. The graph of f prime, the derivative of f, consists of 2 line segments and a semicircle. So these look like line segments and they are line segments. This looks like a semicircle and it is a semicircle. But we would not be able to confirm that if they didn't tell us. Okay, they will always tell you that. All right, part A. Does f have a relative min, relative max, or neither at x equals 6? Give a reason for your answer. At x equals 6, this is f prime. F prime is above the x-axis on the left of x equals 6 and above the x-axis on the right of x equals 6. F prime does not change signs. Therefore, f has neither a relative max nor a relative min. I'm going to say that. F has neither a relative maximum nor a relative minimum when x is equal to 6, since f prime does not change signs at x is equal to 6. That is a requirement for there to be a relative max or min. Okay, on what, part B, so on what open intervals, if any, is the graph of f concave down? F concave down, well, in my mind, f is concave down when f double prime is negative. This is the graph of f prime, so f double prime will be the slope of f prime, the slope of the tangent line to f prime. So where is f prime's slope of the tangent line? Negative. It's negative from x equals -2 to x equals 0, and it's positive from x equals 0 to x equals 4, negative from x equals 4 to x equals 6, and then positive again from x equals 6 to x equals 8. So I will say that, I don't know why I'm cramming it all in right here, but I think I can do it. F is concave down on the intervals from -2 to 0 and 4 to 6. Since, and I'm going to say what I did. I looked at the slope of f prime, so that is exactly what I'm going to write. Since the slope of f prime is negative on those intervals. Okay? Now, real quickly, it said on what open intervals. They are telling you to do open intervals, so do open intervals. If you give them closed intervals, when they specifically asked for open, you quite likely will not get that point. Okay? Part C. Find the value of this limit. As soon as I see a limit, in an FRQ especially, but pretty much any time. I'm thinking I'm going to have to use L'Hopital's rule. So find the value of this limit or show that it does not exist. So it might not exist. Justify your answer. Okay, I'm going to do this down here. Part C. Okay, because L'Hopital's takes some time to work out, right? So for L'Hopital's, we first find the limit of just the numerator. Just the numerator. Let's see if that is 0. And then we're going to find the limit of just the denominator. That's going to be easier. Let's go do that one first. Okay, so if we put 2 in, we're going to get 4 minus 10 plus 6. Yes, that is 0. This one, we're going to have 6 times f of 2. F of 2 they gave me was 1. Minus 3 times 2, that is 6 minus 6, so that is 0. Okay, since those are both 0, that means that we can use L'Hopital's rule. So, the limit that they gave me is equal to the limit of the derivative of the top, which will be 6f prime of x minus 3, divided by the derivative of the bottom, 2x minus 5. I used L'Hopital's rule. You do not have to write a little LH there, but I always do. Okay, if I put 2 into the bottom, I'm not going to get 0 on the bottom. I'm just getting a number on the bottom. So I know that I'm going to be in good shape here. I know on the bottom I'm going to have 4 minus 5. On top, I'm going to have 6 times f prime of 2. Here's the graph of f prime. What is f prime of 2? F prime of 2 is 0. And that's a safe stop spot. So I'm done. Okay, part D. Find the absolute minimum value of f. Candidate's test. On the closed interval from -2 to 8. Candidate's test. X, f of x. Okay. -2 and 8. Start with your boundaries. We also need critical numbers. Now we want the absolute minimum value of f. The absolute minimum value of f. So f prime is equal to 0. F prime is equal to 0 at x equals -1, at x equals 2, and at x equals 6. However, I already said, in part A, I said that f does not have a relative min or a relative max at x equals 5. So do I really have to put that on my candidate's test? No, I don't. At x equals 1, f prime is changing from positive to negative. That means that at x equals -1, f has a relative max. Can a relative max be an absolute min? No. So do I have to put -1 on my candidate's test? No, I really don't. Do I have to put x equals 2 on my candidate's test? Definitely, because that's where f prime is changing from negative to positive. That means f has a relative min at x equals 2. So I'm going to say what I'm doing. F prime is 0 and changing from negative to positive at x equals 2. That's why I'm only putting 2 on my candidate's test. So one of these is going to be my absolute minimum value of f. The values of f go here, right? These are values of x, these are values of f. We want the absolute minimum value of f. Okay, f of 2, they told me in the problem what f of 2 was. F of 2 is 1. So there's 1 down. We don't need to find that one. How are we going to find the other ones? Fundamental theorem of calculus. That's how we find the other ones. So, let's see. F at, because I have f prime. I have f prime right there. So I can do a lot with, I can find any value. As long as I have one value of f, I can find any other value of f using fundamental theorem. So f of 2 minus f of negative 2 is integral negative 2 to 2 of f prime. Okay, I want f of negative 2. I want that. I know that. So 1 minus f of negative 2 is equal to the integral from negative 2 to 2 of f prime. Negative 2 to 2. So negative 2 to 2. I'm using this area and this area. I'm going to take the positive of this area and the negative of this area. So I notice that these two pieces cancel each other out. I'm left with this negative area down here of 2 square units. So 2. That'll be a 2. Negative 2 below the x-axis. So f of negative 2 is equal to 3. F of negative 2 is equal to 3. Now we're going to do the same thing to find f of 8. I think I'm going to come right over here and do f of 8. So f of 8 minus f of 2 is integral 2 to 8 of f prime. We're looking for f of 8. We know f of 2. Okay, so 2 to 8. 2 to 8. So 2 to 8. I want this area right here. It's all above the x-axis, so it's always going to be positive. So I know from right here, this is going to be a 2. This little triangle is 2, right? So I'll put that up here first. 2, whoops, 2 plus, now I need this area. How am I going to get that area? Well, here's a rectangle, there's a rectangle, and if I subtract out that semicircle from the rectangle, I'll get the remaining area. So the rectangle has area 1, 2, 3, 4, 5, 6, 7, 8. The rectangle has area 8. And I'm subtracting out the area of the semicircle. So 1/2 pi times the radius of the semicircle is 2, right? So 2 squared. So 1/2 pi times 2 squared. So that is going to be, let's see, we've got 11 minus 2 pi. 11 minus 2 pi. Okay, so which of these is the smallest? Which of those is the smallest? 2 pi is 6 point something. 11 minus 6 point something is bigger than 1. So 1 is the biggest. I'm sorry, 1 is the smallest. Therefore, the absolute minimum value of f is 1. It occurs when x is 2. All right, let's see how they scored this. Part A. Part A, 1.4. Part A was the neither, and that was just worth 1 point. 1 point for answer with reason. Part B. Part B was our concave down one. 1 point for the intervals. 1 point for the reason. And they made a note on this that said that students must earn the first point. You must get the intervals right in order to get the reason right. To earn the second point. They've been doing that more. It's like sometimes I guess that they see students just spitting out F double prime is negative without having a clue what that means or how to actually use it. Okay, so you need to actually get the right intervals to get that second point. Part C was the L'Hopital's one. 1 point for what they said, limits of the numerator and denominator. In other words, 2 separate limits for the numerator and denominator. 2 separate units. 1.4 uses L'Hopital's rule. And what they said for that is either the derivative of the numerator or the derivative of the denominator must be correct. One of those has to be correct in order to get this uses L'Hopital's rule point. Okay, I'm not going to write all that out, but that's what they said. And then 1 point for the answer. And the answer, to get that right, it must be correct. You must have exactly the correct answer. Okay, which would be 3 in this case. All right, Part D. Part D, 1 point for considers f prime is 0. Did you consider f prime as 0? 1 point for the justification. 1 point for the answer. The justification would be everything, you guys. Everything. Is everything right? And then 1 point for your answer. All right, and that was number 4. And I'm not sure why this was a lower scoring problem. I didn't think that there was anything just too terrible about it.